Hello students. Currently we are learning lesson number 2 Pythagoras Theorem from standard 10th. I am Mrs. Jyoti Bodhe, HM of D.E.S Secondary School. We have till now learnt about Pythagoras Theorem, right angles, their properties, geometric mean and so on. We have learnt one example also based on the same. Now today we are going to learn about application of Pythagoras theorem, application of Apollonius theorem, and we are going to just take few examples of from 2.1, 2.2 and from problem set. Selected ones. Mostly I have tried to cover the star mark ones which you people find slightly difficult. I know my students will be able to solve each and every sum. Let's see now. So now let's start from practice set 2.1. This is the fourth sum and fifth sum. Two sums I have taken. See in this 2.19 figure you can find out it is simple right angle triangle. Clear? SPR. Here we are supposed to find RP and PS using the information given. Information is one side SR is 6. Now here SR, the angle opposite to SR is 30, angle S is 90. So it is logically, if you think, angle R will be 60. And we have learnt that side opposite to 60 degrees is root 3 upon 2 times that of the hypotenuse. Now how I have written hypotenuse as 12? Again using the previous knowledge that side opposite to 30 degrees is 6. That means by 30 degrees property, side opposite to 30 is 6. So hypotenuse will be double of it, that is 12. So length RP, that is side RP, is 12 units. And when we have that, we can find out the side opposite to 60 degrees, that is PS, root 3 upon 2 times of 12, that is hypotenuse. So if you cut 12 by 2, you get 6 root 3. This is the answer of this lesson example 4. Now if we talk about this fifth one, here this similar signs shows that these two sides, that is side AB, is similar to BC. Again angle B is 90 and remaining two sides are similar, means angle opposite to similar sides are always similar. So this, if one is 90, remaining two are 45, 45. So here we have to use the property of 45, 45, 90 degrees, that is the side opposite to 45 degrees is 1 upon root 2 times that of hypotenuse. So let's start. Here AB is equal to BC, isosceles triangle is, and why? Because it is given over here. From that we can say that angle BAC will be congruent to angle BCA. AB is equal to BC. When we want to find out the value of it, it will be 1 upon root 2 times that of AC. So next step is 1 upon root 2 times of root 8, because value of AC has been given as root 8. So 1 upon root 2 into 2 root 2. 8 can be written as 2 root 2, that is because 8 is equal to 4 2s are 8. 4 is a square of 2. So 2 comes out. 2 root 2. Root 2 gets cancelled. 2 1s are 2. 2 units is the answer. 2 units. AB is equal to 2 units and BC is equal to 2 units. I hope here we have used both the properties of 30 60 90 and 45 45 90 and you have understood that. Next is the star mark question. Here in this figure, M is the midpoint of QR. Yeah, angle P is 90 and we have to prove that PQ square is 4 times PM square minus 3 times PR square. Now looking at the figure, you can see there are two right angles. One is PRM and second is PRQ, because for both R is common angle. Okay, so here according to Pythagoras theorem, in PRM, PM is the hypotenuse, PR and RM are the sides making 90 degrees. So PR square plus RM square will give us PM square. So Rm, which we want, can be written as Pm square minus Pr square. If we think of complete triangle PQR, as this is also right angle, here PQ is the hypotenuse, PR and QR are the sides making right angle. So in this, it will be PR square plus QR square or RQ square, you say whatever way you want, gives us PQ square. Basically in the beginning, this again can be written as PR square. PQ square is equal to PR square minus RQ square. Now we have the value over here. Rm plus MQ is complete RQ as M is the midpoint. Yeah. So PQ square is equal to PR square is equal to Rm square, plus we can substitute Rm for MQ because M is the midpoint. So Rm is equal to MQ. So Rm plus Rm, it gives us 2Rm square. If you open it, you get 4Rm square. So PQ square is equal to PR square plus 4Rm square. Now Rm, it is the half of RQ. So that can be written as, and we have got it from the first particular equation, that Rm is equal to Pm square, Rm square is equal to Pm square minus PR square. When you open up this, you get PQ square is equal to PR square, 4 times Pm square minus 4 times PR square. Now 4 times PR square and single PR square, it gives minus 3 PR square. So this can be written as PQ square is equal to 4 Pm square minus 3 PR square. This is what we were asked to prove, and we have proved it. That means in this particular figure, you have to make use of Pythagoras theorem and apply it for 2 different triangles. This question has been asked many a times even in the SSC board question paper. So practice for it, it is actually very simple. Then this is one more star mark question. Walls of 2 buildings on either side of a street are parallel to each other. A ladder 5.8 meters long is placed on the street such that its top just reaches the window of a building at a height of 4 meters. On turning the ladder over to the other side of the street, its top touches the window of the other building at a height of 4.2 meters. So we are supposed to find the width of the street. Now here again, whenever such questions are there, word problems, students, first thing is you try to draw the figure, rough figure in your classroom. Try to draw it, and the figure you will get it should be this way. Clear? The ladder, once B is the point where ladder is kept, once it is 5.8 meters, from B it touches AE at 4.2, from B it touches DC at 4 mm, and this type of figure you will get. As these are buildings, it is understood the angle formed at the base is 90 degrees. The length of the ladder be 5.8 meters. According to Pythagoras theorem, if you consider the first triangle EAB, you can see EB is the hypotenuse, AE and AB are the sides making right angle. So EA square plus AB square will give us EB square. And as we are supposed to find the length of the street, we are interested more in AB. So AB square can be found out from the remaining 2 values which we have, because we have the value of the length of the ladder 5.8, we have the height of that building 4.2. When we solve it, it is 4.2 square plus AB square gives us 5.8 square, and after solving, squaring it, we get 17.64 plus AB square is equal to 33.64. Take numbers together on one side, and AB square, we should take numbers and subtract, we get AB square as 16, which is the square of 4. So AB is 4 meters. Now let us consider the other triangle. The triangle is triangle DCB. Here BD is the hypotenuse. BD you say or DB. I have written DB over here, it is the same. So DC square plus BC square is equal to DB square. So 4 square plus CB square is 5.8 squares. When you solve it mathematically, 4 square is 16, plus CB square gives us 33.64. Taking the numbers together on left hand side, we get CB square is equal to 33.64 minus 16, which gives us CB square is equal to 17.64. Now 17.64 is the perfect square of 4.2. So we got the value of CB as 4.2. So now the street complete, if you think it is AB plus BC, that means you can read it as AB plus BC or BA plus CB, whatever it is, meaning is the same. So AB plus BC is 4 plus 4.2, total it is 8.2 meters, hence the width of the street is 8.2 meters. I hope you have understood it. Practice about the same, you will get the answer. Yeah. Now let's see where do we use this Pythagoras. Actually, Pythagoras theorem is used everywhere. Like it is the basic rule applied for all these construction businesses, architects, designers, engineers, mechanics, everywhere. So these are the real world problem that can be solved using Pythagoras theorem. You can see the different structures over here where Pythagoras theorem has been used, because this is the fundamental thing, basic thing for geometry. They use it everywhere. Now when we have Pythagoras theorem, so there are some applications of Pythagoras theorem. So let's learn more about it. In Pythagoras theorem, the relation between hypotenuse and side making right angle, that is relation between side opposite to the right angle and the remaining two sides is given. Right? So in a triangle, relation between the side opposite to the acute angle and the remaining two sides is the one part, and relation of the side opposite to obtuse angle with remaining two sides can be determined with the help of Pythagoras theorem. Be it any type of triangle, we can apply Pythagoras theorem and solve the problem. Now let us see how. So application of Pythagoras theorem using acute angle triangle and using obtuse angle triangle. Here in this particular diagram, angle C is acute angle. Okay. In triangle ABC, angle C is acute angle. Segment AB is one of the side of the triangle. Segment AD is perpendicular to BC. Yeah. And we have to prove that AB square is equal to BC square plus AC square minus 2BC into DC. Have a look properly on the figure. It has been labeled with side opposite to capital angle B has been written by small b. Side opposite to angle C, that is AB, is denoted by small c and all. So side opposite to A will be complete here, small a. But when we talk about dx, they have given dx as x and BC as a. So if dx is x, then BD will be a minus that x. So BD comes a minus x. Yeah. So this is the explanation of this triangle itself, this figure. Now, when we talk about triangle ADB, as we have learned in the previous part, that perpendicular drawn, the base, it divides that base into two parts. So here, because of that, this perpendicular, we get two triangles, ADB and ADC. So if we consider triangle ADB by Pythagoras theorem, it is c square is equal to a minus x bracket square plus p square. P is the height. Okay. Now when you solve this a minus x bracket square, I hope you remember the things which you have learnt in algebra previously. These types of equations we have learnt, all three properties, a plus x bracket square, a minus b bracket square, a square minus b square is equal to a plus b, a minus c. All these equations you should not forget. Using the same a minus x bracket square, when you open it, the answer is a square minus 2ax plus x square and plus this p. When we consider triangle ADC, which is also a right angle triangle, so by Pythagoras theorem, here AC is the hypotenuse, so b square is equal to p square plus x square. X has been provided. So from here again, p square is equal to b square minus x square. So when you substitute the value of p square from second equation, In the first equation is c square is equal to a square minus 2ax plus x square plus p square. Here instead of p we are going to write down b square minus x square. So x square and minus x square gets cancelled. So what finally you get is a square plus b square minus 2ax, resubstituting c square which is ab square, a square which is bc square, and b square which is ac square. So we get finally ab square is equal to bc square plus ac square minus 2a into x, that is 2bc into dc. This was the case where c is an acute angle. Now in the next, let us see what here. Angle C, this particular triangle ABC, there is one angle C which is obtuse angle, and segment AD is perpendicular to BC, because unless and until we draw perpendicular we won't get the height over here. AD, which has been shown represented by P, is the height, and we have to prove that AB square is equal to BC square plus AC square plus 2 into BC into CD. Now here, as I have already told you, AD is the perpendicular drawn to BC. For this we have to extend BC till D, and then you can show perpendicular to BC. So here let ADBP, which is the height of this triangle, AC has been shown with B, AB with C, BC as A, and DC as X. Here the difference is here BD or DB will be the sum of A and X. So DB will be A plus X. Okay. So using Pythagoras theorem, as it is a perpendicular, so it is making 90 degrees. So here when angle D is 90, AB is the hypotenuse. So here C square will be equal to P square plus A plus X bracket square. Or you can say C square is equal to A plus X bracket square plus P square. Again using the identity first, A square plus 2AX plus X square is equal to P square. Similarly in triangle ADC, we know that D is 90, B is the hypotenuse. So B square will be equal to X square plus P square. So P square is B square minus X square. Substituting the value of P square in equation 1, we get the final answer as C square is equal to A square plus 2AX plus B square, where C is AB, A is BC, B is AC, and finally X is CD. And if we, after completion of this, we can represent it in this manner. AB square is equal to BC square plus AC square plus 2BC into CD. Now Apollonius theorem, actually it is based on these two properties of or applications of Pythagoras theorem which we have learned. Here in triangle ABC, M is the midpoint of side BC, and then we have to prove that, or they have directly given you, while proving you have to prove that AB square plus AC square is 2 twice AM square plus twice BM square. Now only one thing you should remember, students, Apollonius theorem is you can deal with it, you can apply it only when some midpoint has been given, supplied to you. Yeah. Here in triangle ABC, M is the midpoint of side BC. So by this particular word midpoint itself, it tells you that BM is equal to MC or MB is equal to CM. Clear? Because as this is the midpoint, and you have to prove that AB square plus AC square is equal to 2AM square plus 2BM square. So construction is, we have to draw, as we are supposed to use Pythagoras theorem, there has to be 90 degrees. For that we have to draw a perpendicular AD to side BC, that is segment BC. If segment AM, we know it is a midpoint, but we don't know whether it is a perpendicular. So if segment AM is not perpendicular to segment BC, then out of angle AMB and AMC, we can see, look at it, one is obtuse and the other is acute. Yeah, AMC is acute whereas AMB is obtuse. Yeah. Now, so from the previous examples 1 and 2, we can write that AB square is equal to AM square plus MB square plus twice bm into md. Similarly, for obtuse angle, AC square is equal to AM square plus MC square minus 2MC into MD. Considering this properly, as see, we know that M is the midpoint, so BM can be written as MC over here. So we can write, instead of 2MC, we can write 2BM. And when you add both these equations 1 and 2, you get AB square plus AC square is equal to twice AM square plus twice BM square as minus 2 BM MD and plus 2 BM MD gets cancelled, and this is what we prove, and this is known as Apollonius theorem. So based on whatever we have learned, we are going to see some examples from practice set 2.2. Here in this adjoining figure, point T is in the interior of rectangle PQRS. We have to prove that TS square plus TQ square plus TP square plus TR square. So here you do not get confused. How can we show it? Here you just have to understand few things. We have to draw some construction. We have to draw something in one line parallel. They have given that it is a rectangle, so opposite sides are parallel. Given PQRS is a rectangle, point T is in the interior of PQRS, and we have to prove that TS square plus TQ square is equal to TP square plus TR square. So construction is, we have to draw a segment AB which is parallel to SR, clear, such that T is between A and B. Okay. Now when we start with the proof, always you should think of what has been given. So what they have given is PQRS is a rectangle. Yeah. So when it is rectangle, opposite sides are congruent. So here parallel and congruent, PS is congruent to QR. Yeah. So if you consider the smaller rectangle ASRB, here angle S and angle R are 90 angles of rectangle, and side AB is parallel to SR. From this we can say that AS is equal to BR. Yeah. So interior of triangle theorem. Now angle B and angle R are 90, angle A and angle B are 90, all are 90. So it is again ASRB is a rectangle. From here again we can say AS is equal to BR. Opposite sides of rectangle are always congruent. Now if we consider the small triangle PTS out of that, yeah. Now angle PST is acute angle and AT is perpendicular to PS. So we can use the application of Pythagoras theorem for acute angle, and we can get the answer as TP square is equal to PS square plus TS square minus 2 PS into AS. This is the fifth equation we have got. TP square is equal to PS square plus TS square minus PS into AS. Application of Pythagoras theorem. If we consider triangle TQR, you can see over here in the figure. Again angle TQR is an acute angle and BT is perpendicular drawn to QR. So again if we use application of Pythagoras theorem, we will get it as TQ square is equal to RQ square plus TR square minus 2RQ into BR. So look at the figure carefully and just imagine what we are trying to solve and how we are trying to solve. So these two are like, if you subtract, TP square minus TQ square is equal to PS square plus TS square minus 2PS into S, minus of that complete sixth one, that is RQ square minus TR square plus 2RQ into BR. So when we write it together, we somehow, it looks like this, and we are aware that RQ is equal to PS and AS is equal to BR. So after writing for AS, I can, so this gets cancelled actually, 2 PS into AS and 2 PS into BR. Instead of BR I can write AS, it will get cancelled. Similarly the other side. So finally we get TP square minus TQ square is equal to TS square plus TR square, and then rearranging it, take that TS on this side or TQ on that side. Finally you get TS square plus TQ square is equal to TP square plus TR square. Student, looking at the figure, never you should get confused. Yeah. Now we'll take some examples of problem set. This is the fifth example. Find the length of the side and the perimeter of an equilateral triangle whose height is root 3 centimeters. Here, triangle ABC is equilateral triangle, so all three angles are 60, 60, 60. AD is perpendicular to BC. So because of that perpendicular thing, if we consider single triangle, that is triangle ABD, one is 90, one is 60, the third one has to be 30. So, and 30 degrees. And here, considering our application of Pythagoras, it comes AB square is equal to AD square plus BD square. So AB square 2A square root plus is equal to root 3 bracket square plus A square. It gives us 4A square, which is equal to 3 plus A square. Taking A square together, it gives 4A square minus A square is equal to 3. So 3A square is equal to 3. A is equal to 1. Each side out of this 2A, 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 it is 1. So hence the length of each side of the equilateral triangle is 2, because we are considered is 2 into A is equal to 1. So if we talk about its perimeter of triangle will be AB plus BC plus AC, 2 into 1 plus 2 into 1 plus 2 into 1. So 2 plus 2 plus 2 gives us 6. The next one is in an isosceles triangle, the length of the congruent side is 13 centimeter and its base is 10 centimeter. Find the distance between the vertex opposite to the base and the centroid. See here, for this we have to first find the area, and using Heron's formula, that is under root S, area of the triangle is under root S into S minus A, S minus B, S minus C, where A, B and C are the sides. So S is semi-perimeter, that is S is A plus B plus C upon 2. It gives us 36 upon 2 is 18. So area of triangle will be 18 multiplied by 18 minus 13, 18 minus 13, 18 minus 10. So finally it gives us 18 minus 13 is 5, 18 minus 13 is 5, and 18 minus 10 is 8. So here 18 is written as 2 into 3 into 3, 5 into 5, and 8, last 8 has been written as 2 into 2 into 2. All these things is to just find out the square root, as 2 comes 4 times, so we can take it as 2 to the 4 to the 8 to the 16, so 4, 3 into 3, so 3, and 5 into 5 under root 5. Final answer is 60 square centimeter. Now next goes as area of triangle is 1/2 base into height. We don't know the height of it, we know the area, and for this we found out area because we wanted to find out height. So finally height comes as 60 divided by 5 is 12 centimeter. And when you draw the height, we know that the centroid is located at 2/3 of the distance from any vertex of the triangle. So distance between the vertex and the centroid will be 2/3 of the height, which is 12. So final answer is 3 4s are 12 and 4 2s are 8 centimeters. Hence the distance between the vertex opposite the base and the centroid is 8 centimeters. So students, we have learned basic properties and important things of lesson number 2, Pythagoras theorem. I have tried to teach you the way I can. Now rest is up to you. Keep on practicing. Have faith in your own self. Practice all these theorems and nothing is impossible. You will be able to solve all the sums properly. In case if you can't, take help of your teachers or you can contact me. Thank you so much.